This video carries on from the last one on the ionic product of water, and this time explores how the concentration of H+, and therefore hydronium ions, relates to pH. So in the last video we talked about Kw, the ionic product of water, and that it defines the relationship between the concentration of hydronium ions and the concentration of hydroxyl ions. We know the ionic product of water to be 1 × 10⁻14 molar squared. This introduced the concept that if we increase the concentration of hydronium ions, the concentration of hydroxyl ions must decrease, and vice versa in order to maintain this constant. So as one goes up, the other must go down. So we can see why this is important in pH, where pH itself is defined as the negative log of the concentration of H+ ions, so hydronium ions. As an example, we can see in pure water, where the concentration of hydronium ions and the concentration of hydroxyl ions are equal at 1 × 10⁻⁷ molar, we can put the concentration of hydronium ions into the pH equation, and the negative log of 1 × 10⁻⁷ molar is 7. This gives us 7 as a pH value for pure water, which defines 7 as our neutral pH. So we get this inverse relationship between the concentration of hydronium ions and the concentration of hydroxyl ions, where one is high, the other is low, and vice versa. So pH only looks at the concentration of hydronium ions in solution. For example, if the concentration of hydronium ions is high, such as 10 to the 0, which is 1, we get a low pH because of the negative log. This low pH is defined as very acidic. We talked about in the middle at 10 to the -7 that this was neutral pH at 7. And finally, a very, very low hydronium ion concentration, for example 10 to the -14, is 14 pH, and that's very basic or alkali. pH doesn't involve the concentration of hydroxyl ions in solution. However, because of the inverse relationship between hydronium and hydroxyl ions, we can infer the concentration of hydroxyl ions by the pH or the concentration of hydronium ions. For example, if hydronium ions are at a high concentration, like 10 to the 0, then hydroxyl ions will be at a very low concentration. Similarly, on the other side, if hydronium ions are very low in concentration, hydroxyl ions will be high. While the concentration of hydronium and hydroxyl ions will change, or can change, one thing that remains constant is the ionic product of water, which is the result of the concentration of hydronium ions times the concentration of hydroxyl ions. It will always be 10 to the -14, and this is achieved by timesing together the concentration of hydronium and hydroxyl ions. So it's just the balance between the different ions that change depending where on the pH scale you are. Like we talked about, strong acid, you're going to have high hydronium and low hydroxyl. And strong alkali, like a pH 14, you're going to have high hydroxyl, low hydronium.